Welcome to IT Pro TV. I'm your host, Don.
Coming at you live from San Francisco, California.
You're watching IT Pro TV.
Hello, and thank you for watching IT Pro TV, helping you level up with IT learning everywhere you go. I'm your host, Zach Mimbus, for this episode of CompTIA Linux Plus, writing a bash script. I know you want to do that. I want to do that, and Don Pazin is here to show us how to do that. Don, good to see you, sir.
Glad to be here, Zach. And, glad to jump in and tackle a really rewarding topic, which is writing a bash script, because bash scripts can do a ton of different things. And once you learn how to write them, it's the sky's the limits, right, for what you can achieve. It's really just limited by your own imagination. With bash scripts, we can string together tons of commands to do all sorts of really, really cool stuff. So in this episode, we're going to learn how a bash script is structured, how we kind of arrange it, and then we're going to take a look at some of the commands that we can put inside, how we can execute, and get them where they're actually useful on our systems. That's all we're going to be taking a look at right here in this episode.
So, Don, what does a basic script look like?
All right. Scripts are really, really simple. They're basically a text file. So you create a text file and you put a series of commands in there, just one after the other, and lay them out. It's really not a very complex thing at all. However, there are a few little caveats to how we might want to structure. So let's start off with something really simple, and then we'll work up to a little bit more complex. So
Okay.
I'm going to go ahead and on my workstation here, I'm just going to jump into a terminal. And in my terminal, I'm going to create a script. Now, in order to create the script, you'll need a text editor, and you can use whatever editor you want. Maybe a Nano. I usually use Vim. It's whatever you choose. All right. And if you're using one of the more common editors like Nano and Vim, they will actually do syntax colorization or syntax highlighting, and they'll look at your commands that you're typing and change their color. And that's really handy to let you know if you've made a mistake or not. So I encourage you to use one of these editors. If you use older editors or just ones that are off or whatever, then they might not have that. And it's easier to make typos and mistakes, and you spend more time troubleshooting. I'm going to use Vim, and I'm going to create a file, which I will just call sample.sh. Now, you can call the text file whatever you want. Name it anything, all right? The extension doesn't even have to be there. I could just call this sample. But I'm putting .sh on the end just for me as a human. So as a human, I can recognize that this is going to be a bash script. It also tells Vim. Vim will look at it and say, oh, you're writing a bash script, because it ends in .sh. If it ended in .html or .php, it would know it's a web page, and it would colorize based on that. So while the extension is totally optional, it's generally a good idea to put it on there. So I'm going to put it on for mine. And when I go in to edit that, now I'm creating a new file, and I can start to write out some commands. Now, I wanted to start with something simple. And the something simple for me is just going to be echoing out a string, right? The first program most people write in a programming class is hello world. So let's say we want to do that. I can use the echo command, and I can echo out a string, and I'm going to do hello world like that, okay? And I'm just using the echo command followed by a string in quote marks so it knows that's the total string. I've got spaces in my string, so I need the quote marks, and that's the command that I want to run. Now, if I save that, so let's go ahead and save and get out of that, I now have this sample.sh file, and it just has that one line in it, okay? If I try and execute that, it's probably not going to work. I have to say probably, because some distros actually make this magic work, but most distros are not going to allow that to work. So if I try and call it, if I just type sample.sh, well, most systems don't look in the current directory as part of their path, and so they're not going to find it. Now, if you watched our last episode, we actually changed ours to make it look there. So it's going to locate that file, but it's going to say command not found. Sample.sh isn't a command. It's a script. And so if I want to execute it, if I want to actually run it, I've got a couple of choices on how I want to do this. All right. First, the actual executable that I'm going to run is bash. I want bash to run the script for me. And so I could call bash and point it at that sample.sh file. And when I do that, I get hello world. Bash ran that script for me. It knew it was a text file. It read through it, and it executed the commands. Right? But more often than not, we want the script to be able to run on its own. I don't want to have to call bash to then turn around and run the file for me. Right? So we can change that file and make it where it knows to call bash for us. So I'm going to edit that file again. And on the very first line, it's important that this goes in the very first line. you can put a note in the file that tells the system, hey, you need bash to run this, okay? And the way we do that is by throwing a pound symbol in. Now, the pound symbol technically tells the system, ignore this line. What it's really saying, though, is that this line is not part of what's being executed, but it does contain some useful information, all right? And we're going to follow that pound symbol with an exclamation point. And the exclamation point, or the bang, some people call it that, is telling it, yes, this is an ignored line, but I'm about to tell you the environment you need to run this command under, all right? And from here, I can point it to /bin/bash, okay? That's saying if somebody runs this script, you need to process it through the bash shell first. Now, I'm pointing it to /bin/bash. Interesting fact, I'm on a CentOS machine, and there is no /bin/bash in CentOS. And that's because /bin is actually mapped or linked to /usr/bin. But I still want to point to /bin/bash. And the reason I'm doing that is because if I'm going to take this script to an Ubuntu system, to a Debian system, to Fedora, or move it around, I need to point to something that I know exists. And it's part of the file system hierarchy standard and part of Bash's own standard that /bin/bash should be mapped to that command. So by pointing it to this one location, I'm making my script portable where it'll run on multiple systems. Right? Now that I've done that, if I go ahead and save, I can call sample.sh directly and it'll know that it's a bash script. Okay. Now, before I run it, it is still going to fail, right? And the reason is permission denied. I got a different error this time, right? Before I got command not found. It said, wait a minute, this isn't a command. But now it looked at it and it said, oh, it is a command. I can see I'm supposed to run bash and call this and execute it. So it knows that, right? But I'm getting permission denied. And that's because in order for something to execute, it needs execute permissions. And if I do an ls-l and I take a look at my sample.sh right here, look all the way on the left side of the permissions. I've got read and write. The group has read and write, and other, everybody else has read. But nobody has an X. They don't have the execute permissions. So if I want to allow somebody to run this, I need it to be flagged as executable. Also, I could have told just by the color. See how sample.sh is gray? But some of my other scripts are green. And that's because they've been flagged as executable. You can see the X's on the left side where that permission's been given out. So I can assign those permissions by using chmod or change mode. And when I use that command, I can give execute to everybody or specific people. Like if I just want me to run it, I would say u+x followed by sample.sh, right? I'm adding execute to the user. Or maybe I want to do the group as well. And so I could say, UG+X like that, or you can break it up, U+X, comma, G+X like that. Or if I just want to give everybody execute, I can just say +X. And by doing that, that's going to tell it, make it where everybody can execute that. And if I pull up my directory listing again, now I'll see sample.sh is turned green, and I can see where everybody has execute permissions on that. So anybody should be able to come along now and point to sample.sh. The system will know it's a bash script, and it will execute it, and there it is. Now it's a self-contained script. And so when you look at a bash script, I could give you 5 different ones written by 5 different people, and these are the elements that'll be common in between them. They'll have execute permissions, or they should, if you expect them to work, and that first line is going to be specifying the environment. And then after that, every other line is really just a string of commands, command after command after command, that are all going to be run in order, executed from line 1 on down as it moves through that script and performs whatever the actions are. So they're pretty recognizable. When you're looking at text files, you can spot pretty quickly whether or not they're a bash script or just a regular text file.
Don, what are some of the common commands we might use?
There's a ton. I used one right here, which is echo, right? Echo is a simple one. It just says, take some text and throw it on the screen. When you run a script, most of what's going on happens in the background. We don't actually see a lot of what's occurring. And so we can use the echo command to create that output and get an idea of what's going on. We saw some of that in our previous episode on configuring bash. I have this sysinfo script right here, and it shows me information about my system, like the kernel and so on. And I make extensive use of the echo command there. If we take a look at that file, you'll see each line is echoing some data. I'm echoing kernel information or some kind of title. And then after that, I'm running a command to then populate the data that gets shown up on the screen. And so echo is a really common one. All of these other ones are just regular commands. Uname-A, I'm pulling up kernel data, or I'm catting a file. I want to show the contents of that file on the screen. I want to run uptime and show its content. So you can really run any command.
Mm-hmm.
But as far as the logic of a script, there's a handful of commands that we're going to go to on a regular basis. For example, I mentioned echo. There's also echo-e. Echo-e says, I want to echo something on the screen, and then I want to wait for user input. I want to allow the user to type something, right? And in my case, I'm running echo-e to echo that line, and then here's the command that's being run after it. That's the input. I'm kind of feeding it in there. And the reason I'm doing that is so that it's all on one line.
Mm-hmm.
Otherwise, echo would show OS version and then do a carriage return, and then the other data would come up. So it's just kind of formatting. There's the read command. The read command says, if a user types something, I don't want to run it. I want to store it in a variable. It allows us to capture the user input. If you're writing a script that asks people questions, you'll use that read command to gather their data. The test command is another one. In fact, there's man pages for all of these. So if you look at read is actually not a command. If I do like which read like that, actually it did correlate to one, but it's what's called a shell built-in. It's built into Bash. So when you pull up the man page for read, it looks a little bit different. See how it's not showing like a command line syntax like normal? It's showing Bash because it's built into the Bash shell itself. So even though I do actually have a binary on my hard drive, it's never going to get used. Well, at least not while I'm in Bash. It's going to use the Bash one. And so that's basically where that read operation comes from. Test, on the other hand, is a command line utility, and it allows us to compare two things. And you can ask it questions like, is this greater than that? Is this present? Is this empty? Does something exist? It can test all sorts of scenarios and then give you an answer back. That's really useful in a script, right? If I want to run a backup, but a backup's already been done, I can do a test to see if the backup already exists. Or I can run a test to see if there's space on the hard drive. I don't want to run a backup if there's no room to back up. Those are all types of examples of how we could leverage test. SEQ, or sequence. That's another one which right now won't make a whole lot of sense, but I'll show you an example later on where it does. SEQ generates a sequence of numbers. So if you want a sequence of numbers, if I want to generate a list of 1 through 10, I could say SEQ 1, 10. And when I run that, there's a list of 1 through 10. Doesn't look like a very useful command, but I'll tell you, it comes in really handy. I'll show you an example later on. And then we get into really fancy stuff. We can do logic. Remember, test lets me compare two things. We can make decisions based on that. You can use if, then, else. If a test has a certain result, then do something, else do this other thing, right? You set conditions, right? You're testing and making an action and making decisions. So now your script becomes very powerful. Now it's not just a list of commands that all run in order. It's a list of commands that have a little bit of logic, a little bit of thought. And they call that Bash control commands. We're controlling the flow of how those commands are executed and kind of manipulating and changing that workflow. So those are some examples of commands that we're going to make use of quite a bit when we're writing scripts.
Don, how many commands can we string together in a single script?
You can string together quite a few. In fact, I don't know that there is a real limit. I imagine if your script file becomes larger than the amount of RAM you have in your system, that would probably create a problem. But that would require millions of lines in your script. So you can tie a whole lot together. Let me show you an example of a script that I wrote. I have a script in here called newuser.sh. All right. So this is a script that creates a user. Now, I know I can run the add user command and I can add a user in, right? But sometimes there's additional things you want to do when you create a user, maybe like setting up their Bash profile or something like that, setting some permissions or whatever. Add user's not going to do that. So I can take newuser.sh and modify it to do whatever I want. I can also make it do things like check to see if the user already exists. And so that's what I've done. If I edit that file, so let me bring up that newuser.sh. And you'll see where I've strung together 17 commands, right? Each one doing something a little bit different. And if I'm going to zoom in just a little bit here. Whoops. Apparently I'm going to zoom in way super crazy. Whoops. There we go. I can zoom, I promise. So if you take a look at what I'm doing here, that first line, right? I'm telling it where to find the bash environment or the shell to be able to run this. The first one, echo-e username. I'm asking for somebody to provide me a username. Type in a username right here, okay? And then I'm reading it. I'm gathering whatever I type and storing it in a variable. The variable is going to be named username. And then I'm using the ID command against that username. Now, if the user exists, I'll get an ID number back. And the ID number will be 0 or higher. 0 is actually a system ID, and then it goes above. They're usually 500 or higher. But if I get anything else other than a number higher than 0 or higher than -1, then the user doesn't exist, right? So I'm just doing a test. If the ID is greater than a -1, then I'm going to echo on the screen, hey, the user exists, right? But if it isn't greater than -1, then else I'm going to do this. I'm going to ask for a full name, and then I'm going to ask for a password, and then I'm going to string all that together into a user add command to add the full name, username, and password, right? User add doesn't normally put in the password for us. Here I can pass it along because I typed it in the screen. And then after it adds the user, it's going to double check and make sure the user ID actually is assigned. If it wasn't, then some kind of error must have happened, right? But if it was, then the user was created successfully, right? I'm doing tests, multiple tests. I've got if, then, else statements nested together, right? Here's one if statement, and then inside of it is another set of if statements. And you'll see where we close out the if statements by reversing the word and doing fi like that, telling you that the if statement is over. So that's kind of an example right there, how we can string all this together. And when we execute it, let me get out of this. And if I execute that new user.sh, it's going to ask for a username. Now, let's say I want to create a user for John Doe. I already created one way back in the early part of this series. So if I try and create JDoe, I'm just going to type in JDOE. It runs. It sees that user has an ID number, which means they already exist, and it errors out, right? If I do ID JDoe, there it is. He's ID 1003, right? So he already exists. But if I want to create one for Zach, I could say new user.sh and type in Zach. Oh, apparently that already exists. All right, well, we'll create one for Bill.
I'm everywhere.
I'll create a username named Bill. Here we go. So I tried to create Bill, and it says no such user. Bill doesn't exist. And so now I can give him a full name. So this will be Bill. And I should have done a last name. Well, he has no last name. And I can type in whatever his password is going to be. So I'll type in a super secure password. And that's going to go and assign it. And permission denied. I'm logged in as a regular user, so I'm not allowed to create users. I would need to sudo this, and then it would execute and actually create the user. So that shows that kind of workflow that was going through. And notice I got permission denied, and so then I got that error message. An error occurred while creating the user. It failed to create it, and that was all part of the script. Just stringing all those commands together to achieve really kind of a nice little workflow right here through the CLI.
So Don, are there other logic commands similar to if-then?
Yeah, absolutely. I mean, there's a lot of stuff you can do. I mentioned the test command earlier. I didn't actually use it. I was using the ID command to verify whether a user existed or not, right? But I could use the test command to check for that stuff as well. And you kind of get some logic out of that. There's also for, do, and while loops. Okay, these are a little bit different than if and then because what they're doing is checking to see like not if something is there, it's there, and you're saying for each instance of something, I want you to do an activity. Or while a condition exists, I want you to do something. And when the condition no longer exists, I want you to stop. So if I want something to run from like 5 p.m. to 6 p.m., I could do a while. It said while the time is between these windows, I want to execute whatever. So those kind of increase that logic. And let me show you a few examples of how we would leverage these. And let me just start with test, because test is pretty easy, and we'll get a chance to kind of see how that works. So let me create a new script. Let's say that I wasn't concerned whether the user existed or not. I just wanted to know if they already had a home directory. Some distros won't create a user home directory until they log in the first time, so you can kind of use it as a test of whether or not they've logged in. So if I want to write a script that tests to see if a user has a home directory, I can't use the ID command for that. That's just an ID number. So I want to test for the existence of a folder. So I can create a script. I'll just call it home folder test.sh. That's what I'll call it. All right. And in the script, I'm going to start off just like I always do with, pound. Get back in here. There we go. I forgot to get in insert mode. And when you do a pound in Vim, it starts to go into macro mode, which is a mess. So I'm going to do pound !bin/bash. So now it knows that that's the environment I want to run in. And I'm going to do a echo-e, and I'm going to prompt for the username. So somebody's going to type in a username, right? And from there, I'm going to read that into a variable called username, just like before. And then this time, I'm going to use the test command to find out, does that user have a home directory? Not is it defined in their user account, because it's always defined there, but whether the folder itself actually exists. And so I'm going to do a test-d. -d tells it to look for a directory existing. And I'll say /home/$username. Okay, so that's looking for, if I typed in dpossett for the username, it would be looking for /home/dpossett, right? Using that variable, whatever the user types here is then going to be kind of reflected right here. Now, it's going to run a test, and it's going to determine if it exists or not, right? And so then, if it passes, I need to tell it what to do. And so I'll use a double ampersand here to tell it what to do if it passes, okay? So if it passes, I want to echo home directory exists. All right? And then I'm going to use a double pipe. And the pipe character, if you're not familiar with it, it's usually right above your enter key on the keyboard or tied to the / key. It's just the vertical line. And I'll do 2 of those. And so now if the test fails, the home directory doesn't exist, then I'm going to echo a different message. I'm going to echo home directory does not exist, like that. Okay, so now I've got these 2 different conditions, 2 different actions that are going to occur based on what that test command returns. Now, if I had a typo or a mistake in here, this might break, but I think everything is good. This is where the syntax highlighting comes in really handy. Everything looks right. So I'm going to go ahead and save that. I'm going to make it executable. So that was my home folder test. And now I can start calling that home folder test, and I can look for some users. So let's say that that John Doe character exists. So I could type JDoe, and it's going to look. Oh, shoot. Sorry. I was passing it as an option, which you can actually do. But in my case, I forgot that I was prompting for it. So I need to type in JDoe. There we go. And it looks and it sees that John Doe's home directory already exists. I tried to create Bill earlier, right? So if I go and try and look for Bill, it's going to look, home directory does not exist. Okay, it's just running that test in the background and validating whether or not that directory even exists. So if we were to do like a test -d/home/Bill and just run the test, see how I don't get anything back? Because it's not designed to return to humans. It's saying, after this runs, tell me what to do if it passes, tell me what to do if it fails. If I don't tell it what to do, then it does nothing, and we get the end there. So test is an example of a command that's really built for scripting.
Is there ever a right, wrong way to script something?
There really isn't. In my earlier example, I used the ID command to find out whether the user existed, which is a great way to test that out. I could have also done like a grep of the /etc/passwd file and looked there. That's another way. I could have checked for a home directory and used that as the way that I gauge it. What you'll find is that in the Linux world, there's almost always more than one way to do something, right? And when you're given that choice, when you have like 5 different ways to do something, you need to try and figure out which one's the most efficient, right? If I'm checking the home directory to find out if a user exists, well, the problem is maybe a user was created with one name and then the account was renamed later. When you rename an account, the home directory keeps the old name, not the new name. So in that scenario, it would fail. I wouldn't see the directory even though they actually do have a directory. So while I could test that way, it's not perfect. Versus checking the ID number. A user will always have an ID number. They can't not have one. Is that a double negative? That is a negative. They have to have one is the point. And so, so using ID is a better option. So you need to consider your options. Sometimes it actually doesn't matter though. Sometimes you'll find more than one way to achieve something and they both work just fine. Let me show you some examples of that. I'm going to use, I mentioned for and while earlier, right? So let me give you some examples. I'm going to solve the same problem 2 different ways, one by using for and one by using while. So let's say that I need to create 10 files. And these are going to be note files or videos or something like that. I need to just quickly create 10 files. Now, I know that if I make a directory, I'll just call it test1, and I could go in here and I could type touch video1.mp4, and I just created one. And then I could run it again, touch video2, and so on. But what if I needed 1,000 of these files? That would take a long time. So I want to do this programmatically. I want to write a script that creates these files, okay? So to do that, let me create another directory. I'll do test2. I'm going to write a script using the for command. And remember that sequence command that I mentioned earlier? Sequence can generate a list of numbers. So I can generate a list of numbers like 1 through 10 if I want to create 10 videos, or 1 through 1,000 if I want 1,000 videos. And I can use for to say for every number in that output, run a command. Okay, so let me show you what that would look like. So I'm just going to create a script called videos.sh, and I'll do the pound symbol, exclamation point, /bin/bash. And then I'm going to come through and set up my logic. I'm going to say for file num. File num's a variable. So I'm going to create a variable. And for that variable, I'll say in, and then I'm going to do it's a tick mark or a backwards apostrophe. It's at the top left of your keyboard. So I'll do the tick mark, and I'll say seq10 and another tick mark to close that off. That's going to tell it to run the sequence 10 command. And so that's going to generate a list of numbers 1 through 10. And I'm saying for every one of those, 1 through 10, they're going to be stored in file num. For every one of those, I want to run a command. And I'll say do, followed by what that command is. And in my case, the command is going to be touch video $file num .mp4. Okay. Now, $file num, that's a variable. Okay. It's going to identify that as the variable, and it's going to insert that in that file name. Okay. Video is going to be just part of the file name, and .mp4 are going to be part of the file name. But $file num will be expanded to whatever's stored in there. And it's going to iterate 1 through 10. This should create 10 video files for me. And once that's done, I just need to add one more line that says done. When you use the do command, you've got to use done to close it off. All right. So here I'm saying for that instance of numbers, I want to perform an action. So I'm going to save that. I'll make it executable, or I could just call bash, I guess, but I'll make it executable. And then I will run it. And when I run it, I get nothing back. Well, it's because I didn't echo any commands. If I didn't get any errors, you get nothing back. But if I take a look in the folder, I now have video 1 all the way through video 10.mp4, right? So we achieved our goal right there by using for. So I know there's a way I can do it using for. Or I could go and do a while and achieve the same thing. So let me make another directory. This will be test3. All right. And this directory is empty. I want the same thing. I want to create these 10 video files. So I'm going to edit a new file, which I'll just call videos.sh again. And I'll do the pound exclamation point /bin/bash. And on this one, I'm going to go a different route. I'm going to create a variable. And I'm going to set that variable equal to 0. So I'm creating a variable called file num, just like I had in the other one. And I'm starting it at 0. Now, the other one, I didn't have to start at 0, because I was populating it with the sequence commands data, right? But this one, I'm going to populate a different way. So I'm going to start it with a 0. And then I'm going to say while, and then with the while command, you use square brackets, then identify a comparison that says, what are the conditions that this is going to execute? And I'm going to say while file num is, and I'll use -GT, that's greater than. You can do -LT, -EQ. These are all comparisons, right? So I want to do greater than. So while file num is greater than 0, I want it to perform an action. I want it to do something, okay? And so then I will use that do command, just like we did before. And for the do command, I'm going to touch video $file num .mp4, just like before, right? The same command that I used in the other script, okay? But after it runs, I'm then going to say file num equals, and I'm going to change the variable, okay? Some people do count ups, so they add 1 to the variable. I want to count down. I want to start, if I want 10 files, I want to create the variable at 10, and then with each file number, it decreases by 1, goes down to 9, down to 8, down to 7, and so on. It's kind of reducing it until it gets to that final product, right? So I need to modify the variable. In order to do that, I'm going to have to do a couple of crazy things here. I need to do a $sign to tell it I'm working with an existing variable. And I need to do double parentheses here because I'm going to do a mathematical operation, so it's got to be marked off. And then I'm going to call that existing variable, file num, -1, and then I'm going to close it off. Okay, so when it gets to that point, it's going to decrement it by 1. And then it's going to say done. Okay, but up here, while is going to run as long as file num is greater than a certain number, right? So if I change that number to 10, so let's take, or sorry, if I take my original file number and change that to 10, okay, it's going to run. It's going to see that file number is greater than 0. It's 10. And so then it's going to create a file. And after that, it's going to reduce it by 1. So now file number becomes 9. And then it's going to run again, and it's going to become 8 and 7 and 6 and 5 and so on until it finishes, okay? And when it's done, when it finally gets to 0, then it's going to stop and the script will end. And we can test that out real quick. Let me just save that. And I'm going to run it. And I did save it, didn't I? Oh, shoot. I forgot to make it executable. So let me do that. And then we'll run it. And there's my 10 files. I achieved the same exact thing. I just did it a different way. All right, now, which one was better? If I'm just creating 10 files, it's actually the same. It really didn't matter which one I used, right? The other one was a little bit shorter, so the sequence number one kind of worked out better, right? In this scenario. Now, let's say that I wanted to create 1,000,000 files, okay? With the sequence command, it's generating a sequence of numbers 1 through 1,000,000, right? That's going to consume a good bit of RAM. It's going to tie up the system, and eventually you're going to exceed the environment space that Bash is allowed to work in, and you're going to get errors, okay? That's a problem when you work with large sets of data, which the sequence command would have that problem, dealing with large numbers, okay? I was just dealing with 10, so it didn't matter. It was fine. But 1,000,000, that would be a problem. Meanwhile, here, this was just a variable that stored one number, and it decremented each time. And so it could handle a number like 1,000,000, no problem. It would take a while, right, as it went through and created all those, but it would handle a lot better. So depending on the scale of my operation, the while command may perform better than the for command that I used earlier. Two different ways to achieve the same problem, but different scenarios where one might work out better than the other. And that's what you'll typically find. So if you realize more than one way to do something, just evaluate some of the scenarios and how you plan on using it. It may not make a difference at all.
Well, I, for one, am kind of glad we didn't do the 1,000,000, but I learned an awful lot. I'm sure you did too. Writing a Bash script, wonderful episode. Don, anything else you'd like to say before we go on?
You know, sky's the limits on these scripts. You can really do just about anything. Do be careful with them, though, especially when you're flagging them as executable. Other users, if they have access to the script, they'll be able to run it too. So you don't want to do things like sudoing or moving passwords or whatever through them. You don't want to hard code passwords in a script if you can avoid it, because if someone else gets a hold of that script, they now have your information. It's not encrypted or anything, right? So be careful with that. Also be careful to test your scripts before moving them into production, because they could have undesired effects. They could delete files by accident, and now you've really wreaked some havoc. That's something you want to avoid. So test them thoroughly. And it's always a good idea to put a little documentation. You can use that pound symbol anywhere in a script to put little notes, and now you'll remember exactly what you were doing at each stage along that script.
Thank you, Don. Well done. CompTIA Linux Plus, awesome series. Make sure you watch every episode. I'm sure you plan to, because you know that exam is inevitable. So make sure you pay attention, take extra notes, do extra studies. And in our course library is supplementary information. It is there to do one thing, help you be even more successful. So check that out too. And tell everybody you know about IT Pro TV. You know IT Pro TV is binge-worthy. Thanks for watching. I'm Zach Memis.
And I'm Don Pizzette.
We will see you again soon.
Thank you for watching IT Pro TV.